Okay. One of the mistakes people make most often is that when you're rounding, you can't change the size of the number. If I'm rounding off something like 2,567,425, I can't make that 26. Because 26 is not the same size as 2,569,000. You need a number about the same size. And the reason why it's not going to be the same size is because you're going to forget placeholders. But remember, the placeholders aren't significant. You need them to keep the decimals in the right place. That's why they're called placeholders. But they're not significant figures. So if I ask you to round 15,253 to 3 significant figures, I'd look at it and I'd say, the first sig fig is the 1, the second's the 5, the third is the 2. Behind that 2 there's a 5. So I write 1, a 5, and a 3. But 153 is not the same size as $15,253. If I owed you $15,253 and said, hey, let's round that off. Here's $153. You probably would not accept that as full payment. We're even close to it. It's not the same size. So to keep it the same size, I've got to remember that the 1s in the 10,000s, the 5s in the thousands, the 3s in the hundreds. So I need to keep that in the hundreds. So I have to put these 2 places that I dropped off, I have to put those placeholders back in. And I get 15,300. On the bottom one, if I take the 0.028965 to round that to 3 sig figs, first thing I got to remember is the 0 in front doesn't count, so the first sig fig is the 2, then the 8, then the 9. Behind that 9 there's a 6, so I have to write a 2, that goes to 10, a 290. Okay, because at 10. But 290 is not the same size as the number we started off with. All the digits are way after the decimal point, so I need to keep those in equal place, so I need to include that placeholder and that decimal point. So 0.0290. And that's 3 sig figs, because the 0 in front doesn't count, but the 1 at the end does. Okay, I gave you the where sig figs came from yesterday, and how to do it explicitly. There are a few little tricks for figuring out whether you're to do the sig fig. So one of those devices that helps you remember which way to do starts off with a map of the U.S. and the Atlantic Ocean is on the east coast, the right side, and the Pacific Ocean is on the west coast, the left side. And why we're going to use this is to remember things about the decimal point. Because a decimal point is either present, like Pacific, or absent, like Atlantic. So that's why we put Pacific and Atlantic, is so that we can think about present and absent. Okay? Because if the decimal point is absent, so if you've got a number and it does not have a decimal point in it, start at the Atlantic side, the right side, and move your way across until you find that first non-zero digit. That's your first sig fig, and everything after that is a sig fig too. So if it's absent, you start on the Atlantic side, find the first non-zero, that's your estimated number, and everything in front of it's going to count. So if I had 230,000, I look at that number. Does that number have a decimal point? No, the decimal point is absent. So I start from the Atlantic side and go until I run into my first non-zero. and then count the rest, because the 3 and the 2 are the rest, so that has 2 significant figures. And the 3 is my estimated number, because it's the last significant figure. If I give you 1750, doesn't have a decimal point. So I start from the Atlantic and go until I hit the first non-zero, which is the 5. That means that's my estimated number. And then the other 2 count as well. So that's 3 sig figs. So this is just a quick way of remembering the rules that we learned yesterday, or Tuesday. Okay? So that's what you do if the decimal point is absent. You start on the Atlantic side and move your way across. And if the decimal point is present, you start on the Pacific side. Find the first non-zero, and then count everything else to the right. So if I ask you how many sig figs are in this number, you can remember the rule, or you can remember to start at the Pacific side. Pacific's on the left. I start at the Pacific side, and I keep going until I run into a non-zero. That's the 4. And then everything else counts, so this has 2 sig figs, and the last one is my estimate. Okay. If I have 1.2300, the decimal point is present. So I start on the Pacific side, work my way across. The first digit I run into is a non-zero, so that's 1, 2, 3, 4, 5. I count the zeros because everything after the first one you count. So this has 5 sig figs. And the estimated number is that 0 at the end. So this is someplace between 1.23299 and 1.23301. I'm sorry, 2301. Sorry, I threw an extra digit in there. 299,301. Someplace between those two numbers. Okay. So that's a quick and easy way to figure out if it's present. You start at the Pacific and count everything past the first sig fig and beyond. Okay, so that's how you count them. So finding sig figs and counting sig figs. That's what we should have done on Tuesday. And yesterday you should have looked at videos on how to add and subtract with sig figs. I'm going to go through those a little quick. But I really want to focus on the fact that this whole thing is based on we're not sure of the last digit. It might be one bigger, it might be one smaller. So when I add numbers that I'm not sure of, I get a number I'm not sure of. But if I add numbers I have no idea about, I have no idea what the answer is. Okay? So the rule for adding and subtracting is that when you add or subtract, your answer can't be better than your worst estimate. So if I estimated 1 in the tens place and 1 in the thousands place, my worst estimate is I'm not sure if that's 2,000 or 3,000. I'm not sure if this is 10 or 20. Okay. So I have to go with the worst estimate. Okay. And the way you do that is you round it to the one that is furthest to the left. So you find the last sig fig and do the one furthest to the left. Okay? So Like all addition problems, the first thing you have to do before you can add these numbers is line up the decimal points. And then your calculator will add them. Okay. And now we need to start think about Sig Figs. So in that first number, we need to find the estimated number. Since everything's a Sig Fig, the estimated number is always the last Sig Fig. That's the 3. And in 6.4, it's the 4. So those are my estimated numbers. Which one of those is furthest to the left? Why, that would be the 4. So that's where I need to round off. So my last Sig Fig is the 3. Behind that 3, there's a 3, so I leave it alone. Okay, and I end up with 33.3. So the process when adding subtracting is the same. Find the last Sig Fig, and that's where you have to round it. Now, here's why I said it has to do with it can't be better than your worst estimate, can't be better than your worst piece of equipment. Looking at these two numbers, I can tell that they were measured on different pieces of equipment because they had lines in different places. That's how you got different Sig Figs. Okay, so I'm not sure that that's a 4. It might be a 3. It's someplace between 0.3 and 0.5. If I'm not sure that's a 4, what number goes right here? I mean, because when you do the math, you add a 3. Is that really a 0? Well, if I'm not sure that that's a 4, I have no idea what that digit is. So 3 plus I have no idea means I have no idea. And that's why it gets rounded off. Because if I'm not sure that's a 4, I'm really not sure that that's a 3. And I can only keep one number I don't know for sure. Okay. So, a few examples. 4.8 plus 6.8765 grams and grams. Notice they have units. And I always write the units because they're going to be your friend. And my calculator gives me 11.6765, and grams plus grams equals grams. So that's what your calculator is going to say. Your calculator is going to give you the wrong answer. Now you got to think about Sig Figs. What's the last Sig Fig in each of these? Well, it's the 8 in the first one, and it's the 5 in the second one. Which of those is furthest to the left? That would be the 8. So the 8 is after one decimal place, so that's where I need to round it. I need to keep one decimal place. Behind the 6, there's a 7, so I round it up to 11.7. If I'm not sure that's an 8, I have no idea what these digits are, so I'd have no idea what these really are, so I can't include them in the answer. That's the idea.
I have a question.
Yeah, Adam. Aiden.
So do you round the answer, like when you add them, do you round the answer of it, or do you round the
numbers?
6.8765?
Okay, so I round the 11.6765, and I look at that 6, and behind the 6 there's a 7, so I went up to 11.7.
So you round the answer.
Yeah, you round the answers. You don't round the numbers before you round the answer at the end, because we're only adding 2 numbers. What if I gave you a whole column of numbers?
Yeah.
Our goal is to round as little as possible. So round at the end of the problem if you can. Okay? Good question. All right. 520 meters plus 94.98 meters. calculator is going to give you 614.98 meters. Well, the calculator is not going to do meters. You have to do that. But meters plus meters is meters. Now, think about Sig Figs. The last Sig Fig is the 8 in 94.98. And in 520, no decimal places. It's absent, so I go until I find it. So the last Sig Fig is the 2. That 0 is just a placeholder. So now, which of those places furthest to the left? Well, that's the 2. So that's where I have to round. Okay. So I got to keep the 6. The 1, behind the 1 there's a 4. So I leave the 1 alone. I get 61. But 61 is not the right size. To keep it the same size, I have to put a placeholder in for that one I rounded off. Because 610 and 614.98 are about the same size. Okay. So that's pretty straightforward. Now, what is in science? The numbers are not just numbers; they're actually pictures, something about the world. So this math has a story about why it works. And here's the story. Okay, you're trying to figure out how far away your friend is. And you look, and it looks like there's someplace between 510 and 530 meters away. And then they take a tape measure from that spot, and a tape measure that's got a line every tenth, so that they can estimate to the hundredths place. So a really nice tape measure. And they measure off 94.98 meters. That means someplace between 94.97 and 94.99 meters. So when I add those numbers, if I'm going to get a number that's right around 610. I'm not going to be sure of this 10 spot. Because if I'm not sure where I started, I could be off by 10 feet or 10 meters, then I can't say any better in my answer. If I could have been off by 10 meters in the first measurement, my answer can't be better than being off 10 meters. That's the idea behind it. Okay? So you're going to get the problems with Sig Figs here is that people use different tools. When you're adding, subtracting, it's because they use different tools, and you can tell by the decimal places. So 0.0045 plus 2, oops, I got to line them up. 2.113 gives me 2.1175. And those were liters and liters, so I get liters as my answer. Okay. Okay, this rules for Sig Figs. Both these have decimal points, so I start from the Pacific side, and everything after the first Sig Fig counts. So that the 4 and the 5. 5 is my last Sig Fig. 3 is my last Sig Fig, because I'm starting from the Pacific side. And that leaves me with furthest to the left is the 3. So that's where I have to round it off. I'm rounded off to 7 because that's the third decimal place. Behind that is a 5. So I round that up and I get 2.118 liters. So line them up. Find the last Sig Fig, figure out which is furthest left, that's where you round it off. And that process leads to some bizarre answers. Your math teacher hates this. 500 meters minus 126 meters is 400 meters. That's the right answer. It looks wrong, doesn't it? Well, let's see why it's the right answer. So if I take my 500 meters minus 126 meters, my calculator is going to give me 374 meters. Okay. Now I got to think about sig figs. The bottom number is all non-zero, so I just take the last one. The top one's got some zeros. The decimal point is absent, so I start on the Atlantic side and go until I run into a sig fig, and that's the 5. Zeros at the end never count. So I only have one sig fig in my first number, and it's in the hundreds place, so that's where I have to round it. Behind that 3, there's a 7, so I round it to a 4. And 4 is not the same size as 374. I have to put in the 2 placeholders. By the way, don't do this in your math class. Your math teacher isn't working with measurements. They're working with defined things. So we have to do this every time our numbers come from measurements. And it's measurements, it's lousy measurements that make this math make sense. Because if your friend is standing about 500 meters away, someplace between 400 and 600, and they walk 126 meters closer to you, the best you can say is they're now about 400 meters away, someplace between 300 and 500. That's the best you can do. Because you don't know exactly how far away they started, you can't say really precisely where they ended up. And the last one here, 7,200 plus 47 liters. Calculator is going to give me 7247 liters. The 7. Okay. Now, sig fig wise, the 7's my last sig fig. Those zeros don't count, so my 2 is the last sig fig. Go to the left. The 2 is where I have to round it. Behind that 2, there's a 4, so I leave it alone. And I put in the placeholders. And I get 7,200 liters. Which is the same number I started with. And that's because the number I added was smaller than any of my estimates. My estimates were in the hundreds place, and 47 is less than halfway to 100. If I had done 53, we would have rounded up to 7,300. Okay. But that's how you do adding and subtracting. Okay. And you saw some of that yesterday, and I got a few questions from people, and I said I would answer them today in class. So, anybody have any questions about adding and subtracting? Anything that didn't make clear? Okay. You do? Ask away.
What happens if it's a different form of measurement when adding or subtracting?
It can't be. You can't add grams and feet. So it's got to be the same. It's got to be the same unit, or you can't add it. I mean, yeah. What would pounds plus feet look like? So that's a different thing than you do in math. In math class, nobody asked you what it looked like. What it looked like in the real world. Okay. Okay. So I'm going to leave you to practice adding and subtracting. So I'm going to put you into breakout rooms, and I want you to go back and open up the one from yesterday, 36 and 37. Okay. And number 37 is about adding and subtracting. I want you to, I want you to work together, agree on what the answers should be. Okay. And why those answers should be what they are. If you disagree, you should be able to talk about why it counts or why it doesn't count. Okay? Don't trust the other people just because they sound confident. Okay. Then if you finish that, and before I bring you back to the breakout rooms, the next assignment is to do exactly the same homework. I think it's 40 and 41, but the second question is adding and subtracting again. So you can practice some more of them after that. Make sense? So, and I'll pop in every once in a while to see how things are going. If you have a question for me, give me a chat. Hi there. I made it. I can't see anybody though. We had a question for me?
Yeah.
Hey, what's up?
What you want us to do right now is that the significant figure practice number 2.
Okay, it should say number 36 and 37 on it. I took them out of the textbook, that's why.
The one we're doing today is the one from yesterday.
Yeah, the one from yesterday. Yeah. Start off with the one from yesterday, because I was assuming that not everybody felt like they'd mastered that material.
Oh, okay.
Okay, so start with that one. So if you got it done, you can check with other people whether and come with an agreement, or maybe change those answers. Okay. Okay. So the goal is to look at yesterday's, because yesterday's lots of people were confused. Okay. Everybody should be back by now. All right. So welcome back. Okay, so adding, subtracting. Okay. It's all about lining the pieces up. Okay. So that's adding, subtracting. A few people along the way that I talked to said, "Hey, what about the other question, multiplying and dividing? What do we do there?" Well, I got good news and I got bad news. Bad news. Adding, multiplying and dividing is completely different than adding and subtracting. Completely different set of rules. Well, you think about it, it's got to be a different set of rules, because when you add, you have to line up the decimal places. When you multiply and divide, you don't have to line them up. Okay? So you don't even have to do that first step. So it's got to be a different rule. Okay? Good news. The rule is much simpler. In fact, it's so much simpler that you're going to forget to do adding and subtracting. We're going to use multiplication and division much more than we use adding and subtracting. So you're going to be so used to doing multiplication and division, you're going to forget to go back and line up things for adding and subtracting. So that's the bad news. The bad news is a different one, and you're going to forget to do the first one. I taught you the hard one first because this one's pretty simple. And this is the rule. The same number of sig figs in your answer as the least in the question. So you count out how many sig figs the first number has, how many sig figs the second number has, how many sig figs the third number has. If there's 10 numbers, you count out how many sig figs each one of those has. And if the first one has 2, and the second has 3, and the third has 3, and the fourth has 5, the smallest of those numbers is 2. So that's how many you can have in your answer. That's the whole rule. That's why we learned how to count sig figs, is because it's what we'll do most often. Say, for example, I asked you to multiply these two numbers. Well, I'd get out my calculator, push 3.6 times 653, and my calculator would give me this answer, 2,350.8. Your calculator is going to give you the wrong answer because you always have to round it. So I look at that and I say the 3.6 has 2 sig figs because there's no zeros. And the 653 has 3 sig figs because there's no zeros. So which is bigger? Which is smaller, 2 or 3? Whatever the smaller number is, that's how many you have to take. So since 2 is smaller than 3, my answer can only have 2 sig figs. So I go up here, the first sig fig would be the 2, the second would be the 3. Behind the 3 there's a 5, so I round it up. That gets me 24. But if I owed you this much money, you would not take that much money in repayment because they're different sizes, and what I'm missing is that 4 should be here, so I need to put in those 2 zeros. And I get 2,400 for an answer. So count the sig figs in the first one, count the sig figs in the second one. Whatever's smaller, that's how many you have. So hopefully you see why I had you practice rounding off this right number of sig figs and counting how many sig figs there were in the homework last night. So I talked about what we learned one day, we use the next. Here's one of those situations. Division's the same rules. Okay. Count how many sig figs in one number, count how many sig figs in the next, and that's how many you have in your answer. So if I ask you to divide those two numbers, this slash means divide. Okay? If I ask you to divide those two numbers, your calculator screen is going to fill up with numbers. 4.5 divided by 6.245 equals, on my calculator, it says 0.7205764612. That's way too many numbers. How many of those where do I round off? In math class, they tell you where to round off. Here we figure out where's the right place. Well, 4.5 has 2 sig figs. 6.245 has 4 sig figs. 2 is smaller than 4, so I get to keep 2 sig figs. The first one's the 7. The second one's the 2. Behind the 2 is a 0, so I leave it alone, and I get 0.072. Oh, sorry, 0.72. 0.72. Copied badly. So I rounded off to 2 sig figs because the smallest number here was 2 sig figs. What if I multiplied those two numbers instead? Go back and do a little editing. If I multiply those two numbers, my calculator gives me 28.1025. But rounding, all right, 4.5 has 2, 6.245 has 4, 2 is smaller than 4. So I get this with 2 sig figs. The first the 2, the second's the 8. Behind the 8 there's a 1. I leave it alone, and I get 28. Okay. What about multiplication? Well, 2.63 times 18.14 is 47.7082. And notice this is meters and meters, M and M. M times M is M squared. We treat the units just like we treat x's and y's. Treat the units just as a variable. So if you multiply x times x, you get x squared. If you multiply m times m, you get m squared. Okay, but that's the unit part of it. Now what about the sig figs? Top number, no zeros, 3 sig figs. Bottom number, no zeros, 4 sig figs. What's smaller, 3 or 4? Well, that would be 3. So the third sig fig is the 7. Behind that 7, there's a 0. So I leave it alone. I get 47.7 meters squared. So your calculator does most of the work. You just have to count how many sig figs in each one along the way. Sometimes your calculator will just mess with your head. Okay? Because if you push 2.5 times 0.8, your calculator is going to say 2. And m times m is meters squared. And what's going to happen is you're going to see that 2, you're going to write it, you're going to move on, but 2 is not the right answer. Okay? This has 2 sig figs. This, the 0 in front, doesn't count, but the 0 at the end does. Since it's present, we count to there and then everything afterwards. And that's got 2 sig figs. So I have to have 2 sig figs in my answer. So I have to write a number that's the same size as 2, but has 2 sig figs. The only way to write a number that's the same size as 2 with 2 sig figs is write 0.0. It's still 2. But now that 0 is at the end after the decimal point, so it counts. So we saw earlier that sometimes I have to round and get rid of numbers from my calculator, but other times I have to round and add the zeros, the point zeros, on my calculator. And let's look at division with units. Okay, division with units, just look at the numbers. 8,200 divided by 53.87 gets me, on my calculator, 152.2183033. What about the units? Well, grams or G's over M, grams over meters. They don't cancel out, so that's what I'm left with, grams over meters. I just leave them where they're at. If you had 20x divided by 5y, you'd end up with 4x over y. Same idea. Treat the units like variables and do math with them. Okay, so that's my unit's going to be grams over meters. What about sig figs? Well, this has 4 sig figs. This has 2 sig figs. So which is bigger, which is smaller, 2 or 4? That would be 2. So this can have 2 sig figs. The first one's the 1, the second one's the 2, the second one's the 5. Behind that 5 there's a 2, so I leave the 5 alone. I get 1, 5. But 15 is not the same size as 152. To keep it the same size, I have to put the placeholder in. And I get 150 grams over meters. So that's all there is to it. It's easier. So what's going to happen is you're going to get so much, you're going to get the 2 confused. So you always got to stop and ask yourself, any questions about adding, subtracting, multiplying, and dividing? Okay. Just to let you know, we only have to do this every time we do math the rest of the year. So every time you pick up your calculator in my class, you need to stop and think about sig figs. Okay. I apologize a little bit. It's hard for me to know exactly what your previous experience is. So, for a few of you, this is going to be a review. For some of you, it may be new. But we're talking about scientific notation, and I want to talk about how to use it and why we're doing it. Okay. Scientific notation we need because chemists have to deal with really large and really small numbers. And we have to do math with them. Okay? And if you don't use scientific notation, it can get a little bit unwieldy. Okay? You don't need to know this number, but if you were to take 18 milliliters of water, that's like 1/10 of a can of soda. Okay? 18 milliliters of water. In that 18 milliliters of water, there are that many molecules. I would say it out loud, but there's no way to say it out loud because this is the millions, billions, trillions, and that's a really big number. To give you a sense of how big that number is, if you'd started counting at the beginning of the universe 15 billion years ago, and you had counted every second since the beginning of the universe, you'd be in this range. This range. You'd be less than 1% of the way through that number. Okay? So it's bigger than 100 times the number of seconds the universe has existed. That's a number. We have to do math with that number. And the mass of one electron is that number. There is no way to say that number. Okay? If you wanted to count, there are 27 zeros in front of that 9. That's how much one electron is. One electron is tiny. Okay? We have to do math with these. You don't want to type that into your calculator? Are you going to make sure that you got all 27 zeros? Not 29, not 26? Okay? So we need a shorter way to write these. Okay? That's what scientific notation is a shorter way of writing big and small numbers. Now, another name for scientific notation is standard exponential form. And we're going to run into this word over and over again this year, standard. Standard means a group of people picked that this is the right way to do it. Okay? So that means a whole group of people agreed this is the way we're going to do it. Okay? And exponential because we're going to use exponents. Okay? So everybody agreed we're going to use exponents in this form. So in standard exponential form, there's 2 parts to it all the time. A number between 1 and 10. And that's, it can be equal to 1, but not equal to 10. Okay? The reason why they're so specific, because if you follow those rules, every number will have 1 digit, then a decimal point, then any other digit will be after the decimal point. Okay? And then you're going to take that and you're going to multiply it by 10 raised to a power. That's the exponent part. So that really big number, instead of trying to type 21 zeros at the end, 6.02 times 10 to the 23, 10 to the 23rd. So if you multiply 6.02 times 10 23 times, you'll get that number. It's a big number. And that really small number, here it is written a little neater, 9.11 times 10 to the negative 28th. Why negative? Well, because raising something to the negative power means divide by it. So I want to take 9.11 and divide it by 10 28 times. And that's how I get this number. Because dividing by 10 means move the decimal place 1 time over. So, first thing we have to be able to do is take a number and get it into scientific notation. So if you want to put a number into scientific notation, first, you have to figure out where the decimal point's going to go. And a decimal point, there's only one place in any number that will give you a number between 1 and 10 by moving the decimal point. So you got to find that spot. So in 3,240,000, there is only one place I can put a decimal point that will give me a number between 1 and 10. That's if I put the decimal point here. But the decimal point starts there. So I'd have to move the decimal point 1, 2, 3, 4, 5, 6 times. So 6 is going to be my power of 10. So I get 3.24 times 10 to the 6th. Okay? So pretty simple. Find a spot between 1 and 10. There's only one. Figure out how many times you moved it. So 3,240,000 is a big number, so I need to multiply by 10 a lot of times. What if the number's small? Well, we're going to run into this with bunches of things this year. Well, they've got two parts, and if one part gets big, the other part has to get small. So if I make the number bigger by moving the exponent, by moving the decimal place, I have to make the exponent smaller. So I've got a number and I've got an exponent. If one of those gets bigger, the other one gets smaller. Okay? If one of them gets smaller, the other one gets bigger. So if I gave you this number, 0.00045, to make this a number between 1 and 10, there's only one place that I can put a decimal place. It's got to be 4.5. And I'd have to move the decimal point 1, 2, 3, 4 times to the right. I have no idea where those sound effects came from. Okay? So, times 10. Now the question here is that, I know it's a 4, the question is it a positive 4 or a negative 4? Well, look at the number. I went from a small number to a bigger number. The number got bigger, so the exponent has to get smaller. So to go there, if I want this number, I have to take 4.5 and divide it by 10 4 times. So it's 4.5 times 10 to the negative 4th. Okay. Getting back to the original number, just move the decimal point the same number of times as the exponent. Okay? So if you've got an exponent of 8, you're going to move it 8 times. You have to decide which way to move it. And my math teacher taught me left and right, but I prefer big and small. If I'm going to get rid of the exponent, that means it's either going to go up to 0, get bigger, or go down to 0, get smaller. And if the exponent gets bigger, I got to make the number smaller. And if the exponent gets smaller, I got to make the number bigger. So the speed of light is 2.99 times 10 to the 8th meters per second. Write that as an ordinary number. Well, I got 2.99. And I'm going to move the decimal point 8 times. And it's going to go from 8 to 0. Going from 8 to 0 is getting smaller, so I need to move the decimal point to make it get bigger. 1, 2, 3, 4, 5, 6, 7, 8. So I counted 8 times. Oops, raise that 0. So 2.99 times 10 to the 8th is 299 million. Okay. And 4.87 times 10 to the minus 1st. So I got to move the decimal point 3 times. And I'm going from negative 3 to 0. Going from negative 3 to 0 is a positive change. It's getting bigger. So I have to make the number smaller. 1, 2, 3, so I get 0.00487. Get rid of that decimal point because I got rid of those. And I want you to notice something, though. We did math. We should think about Sig Figs. How many Sig Figs did the 2.99 start with? Well, there's no zero, so I start off with 3 Sig Figs. How many Sig Figs does this have? Well, the decimal point's absent, so I start at the Atlantic and go all the way over. It's still just those Sig Figs. I don't change Sig Figs when I'm going into scientific notation. This had 3 Sig Figs. This has 3 Sig Figs. That the Sig Figs don't change. If you go back and look at all our examples, the number I started with and the number I ended with had the same number of significant figures. That the 10 to the power doesn't tell me anything about Sig Figs. Only the numbers in front do. So that's where I want to stop at today. So we'll spend some more time looking at scientific notation. If you've got a calculator, it has a scientific calculator, it's going to come in handy, so you can learn to talk. I'll do the scientific calculator on screen, but there's no way those are they're not as fast as having one in your hand. Okay? So with that, does anybody have any questions for me? Hopefully 35, 36, and 37 make more sense, because then tonight's homework will make sense. And then we'll start being able to use these numbers to describe the world around us. That's our plan. Okay? So there'll be some work. So you practice this tonight. There'll be some more practice over the next couple of days on Friday and Monday. And I'll see you again on Tuesday. Hey, have a great one. Yeah, Carson. Okay, so what notes did you miss?
I missed one, like it was the one that said putting a number into scientific notation.
Okay, so if you go back, my YouTube channel, it's kind of strange, is ALHS Green Chemistry. And if you go back to about this time last year, you will find an old one there. And I actually recorded what I did today on PowerPoint. I don't know if it worked yet. I tried yesterday and it broke. So if it worked, I'll put that one up instead. And it'll be at the top of my YouTube channel. Sound like a plan? Okay, so it's back there from old, or I'll try to put the new one up, but I don't have time right now. I got to